Hi everyone and welcome to this hour. Very exciting 2019 Further Maths Paper 1 Solutions video. Now if you're new, welcome. If you are watching this through YouTube, why don't you do me a favor, and in that bottom corner is a little doohickey that you will be able to subscribe to my YouTube channel. It is a very, very tiny YouTube channel with very few people watching. And if you could subscribe, I would be deeply, deeply grateful. If you're watching it on mathsguru.com, hello and welcome. This site has got so much on it that you can use and watch to revise and all sorts of exciting things. So without further ado, I'm going to kick straight into the Further Maths Solutions, which will project behind me with all of the solutions. Now I'm going to actually cover all of the modules here, but what you'll notice is at the bottom of the screen, it will tell you which specific section of the Further Maths course or the paper we're actually dealing with, so you can fast forward and do all that exciting stuff to get to the sections that you did, because some of this is optional. So let's kick in with our data analysis section, and it says use the following information to answer questions 1 to 3. Awesome. Histogram shows the distribution of population sizes of 48 countries in 2018. Question number 1, the number of these countries with a population size between 5 million and 20 million people. All right, so what we need to do is I'm going to zoom in and I'm looking for between 5 million and 20 million. We're looking at the scale here. There is 5 million and there is 20 million. And so all I did was actually I just went through and said, well, okay, let's count them up. This was 11. This here was 4. And this here is 2. And so 11, 14, 15, 16, and 17, which, as far as I'm concerned, would give B as our correct answer. Now the question went on. Question 2 said the shape of this histogram is best described as, and we have 5 options: positively skewed, no outliers; positively skewed, with outliers; approximately symmetric; negatively skewed with no outliers; and negatively skewed with outliers. So let's just go back and have a look at our diagram again. There we go. Sorry about the fact it's not overly straight on that picture, but what do we notice? It appears to do something like this. And as far as I am concerned, that is very much positively skewed. And this little thing out here, which seems to be significantly far away from the information, would suggest we have an outlier. So for question number 2, I would suggest it was positively skewed with outliers. B is our correct answer. Question number 3 goes on and says, the histogram below shows the population size for these 48 countries plotted on a log 10 scale. All right, this is the first curveball thrown into this. Love, 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 because, yep, you got to know about your log 10 scale. So zooming in a little bit, or zooming out, it says, based on this histogram, the number of countries with a population size that is less than 100,000 people. 100,000 people, oh, let's actually, just to get rid of that, let's actually highlight, which was what I was trying to do. 100,000 people. Do you notice the fact that that's not anywhere on here? I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not overly sure what has happened there when I scan this, but that should be the numbers 0, 1, 2, 3. Now, this is log base 10. So actually, what these numbers stand for in this situation here is 10, then 100, 1,000, 10,000, and 100,000. So there we go. So what it wants is less than 100,000. It is looking for me basically to draw a line here and then add up the 2 bars that I have, which gives me 7 and 1. And so as far as I'm concerned, that would be 8 countries, and our answer would be D. Question number 4 and 5 deal with this data here. The STEM plot below shows the distribution of mathematics test scores for a class of 23 students. And it's always important, as far as I'm concerned, to know that that is a key, and that there tells us how many numbers there were. Now, I'd already said in the question there were 23 students, so there should be 23 numbers in that thing. Question number 4 states for this class the range of the test scores. Well, we know that the range is given by the largest number, subtract the smallest number. Now, obviously, that doesn't mean 9 take away 0, because we have to remember that that 9 actually means that it's 89, and I'm going to subtract from that the smallest number, which is 40, which gives me 49, and I think my answer works out to be D. Yes, it does. Excellent. And for this class, the interquartile range of the test scores. Now, the interquartile range requires me to find the lowest quartile and the upper quartile. So what do I do here? Well, I knew there were 23 data items. So I need to find the person in the middle first. How do we do that? Well, I tend to take the number of data items, which is 23. I add 1 and divide by 2, which gives me that middle data item. So 24 divided by 2 is 12. I'm looking for my 12th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this value here is actually my median. It's the one in the middle. Am I needing that for my interquartile range? Nope, sorry, I don't. But what that lets me do now is work out how to split the lower half of my data and the upper half of my data. So again, what do? I now count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data items. So in this situation, I've got 11 data items, which when I add 1 and divide by 2, gives me the 6th number from the start is going to be, in this situation, my lower quartile. 1, 2, 3, 4, 5, 6. So this number here is my lower quartile. And 6 from the end will give me my upper quartile. 1, 2, 3, 4, 5, 6 from the end is my upper quartile. And we should know that the interquartile range is given by my upper quartile minus my lower quartile. Well, my upper quartile was 75. My lower quartile there would be 57. And when I subtract those from each other, I get 57, 58, 59, 60, 18. And so the answer is C. Now, if you see me keep looking off screen, it's because I've got the answers beside me and I just want to make sure that I am, in fact, giving you the right information. The time taken to travel between 2 regional cities is approximately normally distributed. Now, whenever I see this, I actually always draw a normal curve. And I do this with a dotted line down the middle. And then I've got this, because I'm pretty sure it's going to split it up into standard deviations. Now, it says it's got a mean of 70 minutes. So I know that's now 70, smack bang in the middle. And it's got a standard deviation of 2 minutes. That means now I can add 2 minutes on and subtract 2 minutes off from those 70. So I get 72, 74, and 76, and 68, 66, and 64. So now the question is the percentage of travel times that are between 66 minutes and 72 minutes. So between 66 and 72. Now I tend to always shade these in just so I know what area I've got here. Now obviously if you have your summary books with you, you are going to know that you've got all those different percentages of these normal distributions already sorted out. Now I actually know that this distance here is 68, so I already know that that's 68% of my data. And I happen to know that this section here is also 13.5%, which when I add those together gives me 81.5%, and that gives me D as my correct answer. Question number 7 of the data analysis section. The volume of a cup of soup served by a machine is normally distributed with a mean of 240 ml. So once again, I always draw my normal distribution. So this is 240 ml, thank you very much. And a standard deviation of 5, so sigma is equal to 5. The fast food store uses this machine to serve 160 cups of soup. All right, I'm gonna highlight that because I've got a feeling it's important. The number of these cups of soups that are expected to contain less than 230 ml. Oh, okay, so I've got to do some marks here. I know each one of these is 5, so that's 235, and that's 230. So what I'm looking for is this section here. I'm trying to work out how much of a percentage is in that small section there, all right? Because if I've got a percentage and I've got a total number, 160 cups, I can work this out. Okie dokie, so let's see, what is that percentage? Well, we knew that this section here is 34, and we know that's 13.5, and we know the whole half of that section was 50%. So if I do 50%, and I subtract from that 34, and I subtract from that 13.5%, then I'm going to work out what percentage. Now, again, you may have in your summary book those actual percentages, but I'm going to do my CAS calculator. I'm going to load it up, and I'm going to do 50 minus 34 minus 13.5 gives me 2.5%. So that's the area. So what I now need to do is work out 2.5% of 160. Again, loading up my CAS, I can now do 2.5 divided by 100 to turn it into a decimal and multiply that by 160, and that gives me a total of 4. So B is my correct answer. Percy conducted a survey of people in his workplace. Go Percy. He constructed a two-way frequency table. Now, when I think about two-way frequency tables, I know that I'm going to have something looking like this. I'm going to have 2 options along the top and 2 options down the side. Awesome. Containing 2 variables. Thank you. One of the variables was attitude towards shorter working days. And there we go. There are my 2 choices, for and against. And it goes, the other variable could have been. Now, again, we're looking here for an option that has two choices, that can give me two choices to go in my table. So, age in years, nah. Sex, male or female, I'm thinking that might be it. Let's just check. Height, centimeters, nah. Income, nah. And time spent in minutes, none of those are useful. So question number 8 is B. Notice how I eliminated all those other questions just to make sure. Oh, we're getting better now. Use the following information to answer questions 9 and 10. Right. Least squares line is used to model the relationship between the mostly average temperatures and latitude recorded at 7 different weather stations. And when I do these questions, or when I look at these questions, I actually highlight them to make sure I remember which is which. Okay, now I always remember that this one here is my gradient. Yes, it is my gradient. Okay, that's my slope. That tells me whether things are increasing or decreasing. When the numbers in this equation are correctly rounded to 3 significant figures, the equation will be, well, I've got 42.9842. When I round that to 3 significant figures, I know that I'm effectively doing my first 3 non-zero numbers. That's those. The 8 changes the 9 into a 0, which makes that 43. So I know this first thing here has got to be 43.0. And if I do it again with minus 0.877447, 3 significant figures, well, the first 0 doesn't actually count. I start counting from that 8. So 3 significant figures, the 4 does not change the 7, and so that stays as minus 0.877. And so let's see which one fits. I'm looking for 43.0. Well, D is no, B is no, and A is no, so that maps it down to C and E. Now, good multiple choice practice here is the fact that there are always probably 3 answers you can discount and 2. It'll always be between 2. So average temperature, latitude, latitude. So what are we looking for? Minus 0.877. E must be my correct answer. Okie dokie, the coefficient of determination was calculated to be that. The value of the correlation coefficient rounded to 3 decimal places. Okie dokie, well, what we're doing is we're trying to say is what number, when it was squared, gives me 0.893743. So we can actually work out what that is by the square root of 0.89374 and 3. Once again, firing up my calculator, thank you very much, we will now say the square root of 0.893743 gives me 0.945, and E is my correct answer, yes? Well, actually, what do you notice? Well, it's obviously not B, C, and D, down to those 2 choices. One of them is negative, and one of them is positive. Which one do we choose? Well, we notice that when we go back to this previous question, which said it's useful for that formula is useful for 9 and 10, because my gradient is negative, then A must be the correct answer. I must have a negative correlation coefficient. Moving on to question number 11, we have a study conducted to investigate the effect of drinking coffee on sleep. Fabulous. This study, the amount of sleep in hours and the amount of coffee drunk in cups on a given day is recorded with the following summary statistics, and sorry for turning the page, on average for each additional cup of coffee. So having drawn that set of axes, I know that I'm going to put coffee on the bottom and I'm going to put sleep on the side. Yes, in my way. So I know that this is X. Now this table confused me. When I first saw this question, I was like, what are they trying to tell me here? But again, what do we notice? We've got means and standard deviation. So coffee, that happens to be X bar, and this happens to be Y bar. It's the mean. And we know the mean is this X bar and Y bar stuff. And do you now see where we're going? It's that formula, isn't it? Then we've got standard deviation. So that would be S of X, that would be S of Y, and this would be our value of R. And actually, I don't need to do all the working out. What I do need to do is work out my slope, which is given by B is equal to R multiplied by S of Y divided by S of X. So we know the value of R is minus 0.770. We're going to divide that by S of X, which is 1.56, and multiply that by 1.12. So firing up my calculator, what do we see? Let's just do that. Let's do shift and equals. Nope, let's do that again. Let's do that. So we've got negative 0.770. We're going to multiply that by 1.12. And I'm going to divide that by 1.56 and hit enter, and we get negative 0.55. Well, basically, just looking at this, there's only one that has the 0.55. Negative suggests decrease, and so A was my correct answer. Moving on to question 12, it says the table below shows the values for two variables x and y. The associated scatter plot is also shown with the explanatory variable as x. Explanatory, thank you very much. The scatter plot is non-linear. Oh, I'm going to do a transformation. Haven't read the rest of the question, but let's see where we go. A squared transformation applied to the variable x can be used to linearize the scatter plot. The equation of the least squares line fitted to the linearized table is closest to, or the linearized data is closest to. Okie dokie, well I need to do this all on my calculator. So let's go to a menu and let's go to statistics, and we'll notice that we got some data in there already, but let's get rid of it. So I'm going to type all of this data in and see you in just a moment. Okay, so having got my data in, it's always a good idea to check that they are actually correct. You've got the right values in there, otherwise it's all going to go horribly wrong. We're doing an x squared transform, so I'm going to now say to my calculator, well, I want to call that something sensible, please. So let's do that as XSQ, which is going to stand for x squared. Hit enter, and now I'm going to say, well, can you please now do a calculation for me? And what I want is, I want that to say, well, let's take the value of x, if you would please, and square it. Hit enter, and it auto-populates my screen for me. There we go. So there's all of my data in there. What do I do now? Well, I could graph this thing, but the question doesn't want me to graph it. It wants me to find our least squares line. How do we do that? I'm going to hit calc, regression, linear regression. Now, what do we do? This is an x squared transform, so the x squared has to go along the bottom. There's my x squared. My y is up the side, and when I hit OK, then what do we do here? Now obviously I can choose two different ways that formula can be, but as it turns out, I've already got it set up for a plus bx. So the a value is minus 1.33, and when we look at our solutions, well, that gives us either a, b can be the correct answers. They're no good to me because they don't fit what I'm expecting, and my value of b works out to be 0.5455, which is 546, and so the question is it A or is it B? Well, because we've done an x squared transform, the value is B, because we want x squared along the bottom. So in this particular example, what are we doing? We're using following information for questions 13 and 14, and we've got the time in minutes that Liv ran each day was recorded for 9 days. Thank you very much. These times are shown in the table below. Awesome. And we have a time series plot generated from that data. Okay, so question number 13 says, both 3 median smoothing and 5 median smoothing are being considered for this data. Thank you. Both of these methods result in the same smooth value on day number. Okay, so we've got to do some 3 mean smoothing. Let's see what actually happens there. So when we do the 3 mean smoothing, we're going to choose 3 values, and we're going to work out which one is the middle horizontally, which one the middle vertically, and we're going to do a dot. So if I look at my first 3 points, 1, 2, 3, which one is in the middle? Well, obviously it's this one here. 2. If I'm looking horizontally, what about if I'm looking vertically? Well, this seems to be the bottom one, then it's this one, and then it's this one. And so this here is the point I'm going to draw. So let's rub out, this working out here, because we don't want that anymore. And I'm going to move on to the next 3 points. 1, 2, 3, and we just repeat. So middle one is obviously here in terms of horizontal, but this one here means I'm going to do a point there. So I'm going to rub that out. Here is my point here, and then just get rid of those. And I'm just going to keep doing this until I get to a point where I've got all of my 3 mean smoothing and 5 mean smoothings done. All right, I'm going to do that now to save you watching all of this, and you can come back in just a moment. And there we go, there are my 3 mean smoothings done. How do I do my 5 mean smoothing? Exactly the same way, but this time I'm going to look at 5 data items at a time. So 1, 2, 3, 4, and 5. Let's look at those first. And so the middle one is obviously here, sort of day 9, and then we've got 1, 2, 3. So here actually is my middle value. I'm going to get rid of that yellow so that I can color it in green, but that doesn't seem to give me, because remember we're looking for the one where the 3 mean smoothing, what am I doing? The 3 median smoothing and the 5 median smoothing are exactly the same. So what I'm going to do is, again, I'm going to carry on with these and come back to you when it's all done. And yes, what we've now noticed is, and I've drawn the dot over each other, that in fact on day 7, the 3 median smoothing and 5 median smoothing actually give the same point. So let's mark that in as day 7. So it's question 11 was in, question number 13 I think is in fact E. And let's move on to question 14. The least squares line to be fitted to the time series plot shown above. Okay, right, display day number as the explanatory variable. Day number as the explanatory variable. What have I got to do? Yep, I've got to do all this on my calculator again. Okay, so loading up my CAS calculator, I have now put in all of that value. I don't need to do any of these log square transforms. They're looking just for the linear stuff. So I've got my data in. Let's scroll this up a little bit and get the question back in and bring back my CAS. Right, calc, please, if you be so kind. Regression, linear regression. My X list in this situation is main X. My Y list is main Y. Selecting those and hit enter. And what do we get? We get A as 28.5. So what are we looking for? Day number is equal to 28.5. So automatically we are going to only have B and E as my answers or suggested answers. And B, my gradient is 1.77. So there we go. So now looking at this here, we've got B and E. What is it we're looking for? Well, my time is high, my day number is here. So there's my day number. It's actually E that I'm looking for as my correct answer. In this question, we're going to be using this data, and the time series plot below shows the monthly rainfall at a weather station in millimeters for each month in 2017. Question number 15, the median monthly rainfall for 2017 was closest to. Right, well, to find the median, very much like the 3 median smoothing and the 5 median smoothing, I can do exactly the same thing here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 points. Add 1 is 13, divide by 2. So I'm looking for somewhere between the 6th and the 7th point. So where is the 6th and 7th point? 1, 2, 3, 4, 5, 6th and 7th point from the bottom. Okay, so there's 1, 2, 3, 4, 5, and there's my 6th. And can we find my 7th? I think it's probably there. And so roughly halfway, that's just under 100. That's just over 100. So I reckon D, 103 would be my correct answer. And going on, question 16 says, if 7 mean smoothing is used to smooth this time series plot, the number of smooth data points would be, well, I tend to go, well, right, we got 7 mean smoothing. So I go 1, 2, 3, 4, 5, 6, 7. Puts me at that end point. So what I do is I say, well, where would my end point be if I was doing my 7 mean smoothing? It puts me there. Well, how many points can I move to the right to allow me to keep doing that smoothing? Well, 1, 2, 3, 4, 5, and the one above there would be 6. And so question 16, C is my correct answer. Okay, and welcome to this section now on the recursion and financial modelling. Still part of the core component for further maths, but we're on question 17 already. And it says, consider the recurrence relation shown below when you've got A0 equals 3, and to get to the next term, you double the previous term and add 4. That's exactly what this is saying here. Okay, my first term is 3, and to get to my next term, I double it and add 4. Okie dokie. So the question says the value of A3 in the sequence is generated by the recurrence relationship given by, okay, so A3 we know is 2 times A2 plus 4. All right, so the first thing is I've got to now work out what this value of A2 is. Well, I can do that. I know my first term is 3, and to get to each subsequent term, I'm going to double it and add 4. So 3 times 2 is 6, add 4 is 10. Double it, 20, and add 2 is, add 4 is 24, and there we go. This is A0, this is A1, and this is A2. So that gives me 24. So that's 2 times 24 plus 4. And which one does that match? 2 times 24 plus 4 would give me D as my correct answer. Question number 18. The value of a compound interest investment in dollars after n years, VN, can be modelled by the recurrence relation shown below. And again, V0, that's my start amount. And to get to my next amount, I'm going to take my previous amount and multiply it by 1.01. The interest rate per annum for this investment is, well, 1.01 is the same as 101%, all right? Or a 1% increase. Yes, so 1% increase, or alternatively, my interest rate is 1%, and so my value, correct answer there, is in fact C. Yay! Question number 19, loving these questions so far. Hopefully you're finding this okay. Jeff purchased a computer for $4,500. He would depreciate the value of his computer by a flat rate of 10%. So that means there is a fixed amount of money going to be taken off this computer every single year. Okay, per annum. A recurrence relation that Jeff can use to determine the value of the computer after n years is given by, well, we know that V0 is going to be 4,500. And we know that it's going to depreciate by 10% of that initial price every year. So 10% of 4,500, I know, is $450. So what are we going to do then? Well, we now know that V0 is equal to 4,500. And to get to my next term, I'm going to take my previous term and take away the $450 that I'm going to have, right? So each year, which is what this says here, I'm going to take away another $450. Does that fit anything I've got in here? I should Coco. So question number 19, I think A was the correct answer. Okay, consider the following amortization table for reducing balance loan. Awesome. What do we have? Payments, interest, principal reductions, and balance. The annual interest rate for the loan is 3.6%, and this question here was very much a case they wanted 3.6% per annum. Now, obviously, we know that if we're going to pay on different amounts like weekly, fortnightly, monthly, that 3.6% has got to change. We're going to divide it by all sorts of different values and turn it into percentages and what have you. The way I did this question was I said, right, okay, well, I know that on a balance of $300,000, I have an interest of $900. So can I work out what my interest rate would have been, or whether it was weekly, fortnightly, or monthly? And this is what I did. So I loaded up my calculator and I said, okay, so what I'm now going to do is I'm going to try each of these weekly, fortnightly, monthly, quarterly, and yearly. So let's look at weekly first. So 3.6% per annum. There are 52 weeks in a year. And I divide by 100 as well because I'm turning a percentage into a multiplier. Gives me that rather bizarre number. Don't care what it says, don't care what it means. There's my multiplier. Now if I multiply that by 300, 1, 2, 3, I get an interest payment of $207.69. Is that $900? Nope. So it can't be weekly. So A is not possible. What about fortnightly? Well, how many fortnightlies are there in a year? Well, there's 26. So what I'm now going to do is, because the great thing about the CAS calculator is I can change that value to 26, hit enter, and it ripples through and changes all my values. This time, 415? Nope, so it can't be fortnightly. What about monthly? Well, again, how many months do I have in a year? There's 12 months in a year, so divide by 12, hit that, and biff, puff, poof, out comes 900. So I now know, just by process elimination or doing it there, and I'm sure there are other ways of doing this question, that actually C, monthly, is my correct answer. Okay, here's question 21. The graph below shows the value in dollars of a compounded interest investment after n compounding periods, Vn, for a period of 4 compounding periods. Okie dokie. The coordinates of the point n are equals 2 are 2, comma b. Okay, so there's my coordinates there. Now, the great thing is, because this seems to be linear, then I can actually work out my values by working out what the multiplier is. So I know that I can work out the multiplier to get from 500 to 580 by doing 580 divided by 500. Load up my calculator. Let's leave that there. 580 divided by 500, calculator please, give me 1.16, which tells me that to go from here to there, I need to multiply it by 1.16 as well. So firing up my calculator. So if I do 580 multiplied by 1.16, gives me 672.80. So 672.80 seems to give me C as my correct answer, but I'm now just going to check that when I do that 672.8 and multiply it by 1.16, I get the next answer, 1.16. And I get 780.448, which is 780.45, and I'm fairly confident C is my correct answer. Okay, so question 22. A machine is purchased for $30,000. It produces 24,000 items each year, and the trick to this question was each year. Yes, the value of the machine is depreciated using a unit cost method of depreciation. After 3 years, there we go, we need to be careful. The value of the machine is $18,480. A rule for the value of the machine after n units are produced, Vn is given by. With question 23, financial solver question. Love. Joseph borrowed $50,000 to buy a new car. Interest on the loan is charged at 7.5% per annum, compounding monthly. All of this stuff is really important to me. Joseph will fully repay this loan with 60 monthly repayments over 5 years. Immediately after the 59th repayment is made, Joseph still owes $995.49. Now, interestingly, the trick to this question, I believe, is that $50,000 I'm not interested in. He's got $995.49 to pay back. The value of his final repayment to the nearest cent will be, right, let's see. Number of payments, well, he's got one left. He's gone from 59 to 60, so he's got one payment. The interest rate we do know, it's 7.5% per annum. And the payments per year were 12. I know we're not making 12 payments, we're only making one, but because we're compounding monthly, our payments per year and compounds per year are in fact 12. My principal value in this situation is 995.49. My future value is 0 because he wants to clear the loan. And when I hit PMT, out comes at 1,001.72 cents. So, or 71 cents. Yep, sorry, that was bad rounding, Maths Guru. So question 23, C was my correct answer. Okay, so question 24. Millie's invested $20,000 in an account at a bank with interest compounding monthly. And after 1 year, the balance of Millie's account was $20,732. The difference between the rate of interest per annum by her bank and the effective annual rate of interest for Millie's investment is closest to Bachoosh. Right, we've got to find a difference between the interest rates. So the first thing I'm going to do is I know that to go from 20,000 to 20,732, she's gained $732 in interest. All right, so I'm going to divide that by 20,000, bringing up my CAS calculator. What am I going to end up with? Well, we're going to go, not that screen, let's go back to my main screen. So 732 divided by 20, 123, gives me that, times it by 100 to turn it into a percentage, gives me 3.66%. Okay, so that's 3.66%. We can now use our financial solver to give us our other interest rate. So loading up my CAS calculator, let's see what we can put in. We know that she's investing 20,000, so her principal value is minus 20,000. Negative because she's giving the money back and we don't like that. She's not making any payments. Her future value is how much she's going to have in there afterwards, which is 20,732. Number of payments, well, let's say 12. It doesn't actually matter, not 112. Principal payments per year, compound periods per year is 12 and 12. And so when I hit I%, then what do I get? 3.6%. So now let me have a look. So I've got 3.6%. And so the question says, what is the difference between the two? And that works out to be B, which is 0.06%. This section of the video deals with the module on matrices. Now, not all of you may have done this module, but if you did, these are the solutions. If you're wanting all of the other modules, fast forward through this video and find the module. It's helpfully linked below to tell you which module I'm currently dealing with. Okie dokie. So let's go back and start at the very beginning. Consider the following 4 matrix expressions. How many of these are defined? And when it's defined, it means how many can you do? And in this situation, because we're doing a lovely, easy question where we're adding matrices together, we realize that we can only add matrices that have the same order, the same rows and columns. And as far as I'm concerned, these have the same rows and columns. These do not. That second one does not. The third one does not, but this fourth one does. So how many does that give me? It gives me 2. So there we go. C, 2 is the correct answer. Question number 2 goes on to say, there are 2 rides called the Big Dipper and the Terror Train at a carnival. The cost in dollars for a child to ride on each ride is shown in the table below. Okay, 6 children ride only once on the Big Dipper and only once on the Terror Train. And the total cost in the ride of dollars for these 6 children can be determined. And when you're working out the total cost, we're looking at matrices multiplying together, all right? And that much we can do. So are we going to have 6 times 7, 8? Well, as far as I'm concerned, no, that's not going to give me the right answer. This one is definitely not going to give me, it sort of looks right, but not. This we can't multiply because we have to have them as going in rows and columns. So one has to go across and one goes down. This one here isn't going to work. But actually, the only one that's left is D, and that's my correct answer. Question number 3, consider the matrix P, where P is given by 3, 2, 1, 5, 4, 3. Now, I love these questions. The element in row I and column J of that matrix is given by P, I, J. The element in matrix P are determined by the rule. Now what it's basically saying is, we know for the matrix that this is element 1, 1, and then 1, 2, and 1, 3, and 2, 1, 2, 2, and 2, 3. So what they're basically saying is, for this element here, I equals 1 and j equals 1. So we didn't try and find a formula that when I put 1 in, I equals 1 and j equals 1 in, I actually get the number 3 out. So let's see, 4 minus j does give me 3. Now we can turn around and go, yay, I found it, but don't forget we've got to do more than one number. So A is a possibility, B, 2i plus 1, that's also possible. I plus j plus 1, yeah, that's possible. Oh, I plus 2j, yes, also possible, because that's still going to give me 3. And 2i minus j, all of those work, so that's no good. So let's try the next one. Let's try this 1, 2, where I equals 1 and j is equal to 2. Right, 4 minus j, yeah, that works as well. Oh, what about 2i plus j? Well, 2i is 2, plus 1 is 3. Hold on a moment, b now cannot be the possible. I plus j plus 1, so that would be 1 plus 2 plus 1 would give me 4. That can't be possible. What about the next one? I plus 2j. I plus 2j would give me 5. That's no good. And what about this one? 2i minus j plus 2. So 2i is 2, minus 2 plus 2 is 2. So that's possible. Could give me that one. So we've narrowed it down now to A and E. Let's see whether we can get this one here. So we've got to have now I as 1 and j as 3. Let's see what happens. 4 minus j, yeah, that's going to work. 1. What about E? And the next one, 2i, so that's 2, minus 3, minus 1, plus 2 is 1. Still A and E, no help. Right, let's go to this one here. Now let's have this one then as I is 2, and j is going to be the value of 1. Let's see what happens here. So, j is 1, 4 minus 1 is 3, it's not 5, it can't be that one. So let's just check, is this actually right? 2 i's are 4, minus j is 1, plus 2 does in fact give me 5, and so E is my correct answer. Love these questions. Stella has completed a multiple choice test that has 10 questions. For each question, 5 possible answers, A, B, C, D, and E. Okay, so question number 1, Stella chooses the answer E. That's going to be important because it says this question and next question. It goes on to say, what answer did Stella choose for question number 6? 1, 2, 3, 4, 5, and 6. I'm going to do those 6 little marks to say the questions. And we know she opens up with question E. So what I'm going to do now is look at E, and it says that the next question would be C. So there we go, C. Look at C, the next question would be A. Look at A, the next question would be D. Look at D, the next question would be B. And look at B, our next question would be back to E. So there we go, E is my correct answer. Okay, this question talks about systems of simultaneous linear equations, best represented by the matrix above. Love, 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 love. So the first thing I'm going to do is I'm going to say, well, let's deal with the first row and that column of letters. What do we get? We get 2v plus 2w plus no x is not going to write it, and that's a minus 2, so we're going to make this minus 2y is equal to 2. Let's see whether any of my equations doesn't have that. 2vw minus 2 is 2, 2, 2, 2v plus 2w minus 2y is 2. There we go. So I've already discounted C because that plus there is not correct. Let's do my next equation. So the second row is going to give me 2v, no w's, minus 2x's, no y's is equal to 6. So 2v minus 2x equals 6. 2v minus 2x, yep, they're all there. 2v minus 2x equals 6. 2v minus 2w equals 6. E is now discounted. Keep going. Third row, and those columns of letters, multiply them together. It gives me 2w minus 2y is equal to minus 8. So 2w minus 2, well look, A is already incorrect. 2w minus 2y equals minus 8. 2w minus 2, B and D still in the running. Take it to the wire. And the last one, bottom row of the matrix, and those letters, gives me 2v plus 2w minus 2x is equal to 4. Right, 2v plus 2w minus 2x is equal to 4. D is incorrect. B is my only answer. Okay, our water park is open from 9 AM until 5 PM, and we have a transition matrix here, and I love transition matrices. Basically, it gives you every half an hour. So this half an hour and the next half an hour, a group of children has come to the water park for the whole day. the percentage of children who are expected to be at the slide at the closing time is closest to. Now, all we're going to do is say, well, we know that they're coming between 9 a.m. and 5 p.m. How many half hours is that? Well, 9, 10, 11, 12, 1, 2, 3, 4, 5. So it's 8 hours, which would give me 16 half hours. So now all I need to do is raise that transition matrix to the power of 16 and read off the value that's going to be, what do we want? The slide is going to be in this position here. Can't do that in my head, but I can use my calculator to allow me to do it. Okay, so there we go. First things first, let's create a matrix if you'd be so kind. Where are you, matrices? There. So double click on this will give me a 3 by 3, and typing in the values we get 0.80, 0.2 and 0.4. Let's put this one in there, 0.05, 0.6, 0.1. Let's not keep putting all these point zeros in. The calculator knows what I'm talking about, 0.2 and 0.5. And because we are dealing with effectively getting on to steady states, I'm going to raise that to the power of 16 and hit enter. And you notice that we got lots of disgusting values. And the one I'm looking at is that 0.1379. And I want that nearest to, the nearest percentage would be 14%. And so A would be my correct answer. Question number 7 says the communication matrix below shows the direct path by which messages can be sent between two people. In a group of 6 people, U to Z. All right, so we have sender and we have a receiver. Okay, a 1 in the matrix shows the person named in that row can send a message directly to the person named in the column. And they give an example, not interested in. How many ways can Y get a message to W by sending it directly to one other person? All right, so Y sending to W, but not directly. So that one's not interested. So it looks like Y can send to X and Y can send to Z. So Y can send to X and Y can send to Z. So the question is, can Z and Y send, can Z and X send to W? Well, let's have a look. There's Z. Can Z send to W? Oh dear, no. So that's actually no use to me. Z can't send to W, so that's no good. X probably can then. So let's have a look at X. Can X send to, oh no. X can't do it either. So in fact, the answer to this question is there are no ways. A is my correct answer for question number 7. This question here was a doozy, and it took me some time to see the trick, and I was annoyed with the trick that actually says there are always M planes parked. Right, that number of planes parked is the same. That was the trick to the question. So we have a transition matrix or transition diagram showing the change in location of the planes from night to night. And there are always M planes parked in Melbourne and S planes parked in Sydney. Right, of the planes parked in Melbourne Airport on Tuesday night, 12 have been parked in Sydney the night before. So basically, I now know that 12 planes had moved across from Sydney to Melbourne. So using that information, I now know that 0.48, 48% of the planes that were moved from Sydney to Melbourne were 12, right? So 48% of the total planes. So 48% of some number here gave me 12. So firing up my CAS calculator, and let's clear away what was there before. Yes, I am sure, otherwise I wouldn't ask you. So what I'm going to do now is 12 divided by 0.48, which gives me 25. So 25 planes, yes, were here in Sydney, of which 12 were moved. Now, the interesting thing, and this was the trick to the question, there was the same number of planes stay in Melbourne. So if 12 moved from Sydney to Melbourne, then 12 have to move this way. And again, using exactly the same logic, I now know 20% of some number was equal to 12. And so using my calculator once again, if I do 12 divided by 0.2 gives me 60. So there was 60 there. Oh, sorry, no, that's not there. Try that one again. So 60 were in Melbourne. And when we add those two together, 60 and 25 give me 85 planes in total. Okay, this section of the video deals with networks and decision mathematics. Love, 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 love. Question number 1 in the graph shown above, the sum of the degrees of the vertex. Well, the degree of a vertex is how many edges are coming off. So let's write them down. There's 2, there's 3 coming off of there, there's 2 coming off of there, there's 3 coming off of there, and there's 2 coming off of there. So 5, 6, 7, 8, 9, 10, 11, and 12 gives me E as my correct answer. Yes, it does. Nice first question. Question 2, consider the graph below. The minimum number of extra edges that are required so that an Eulerian circuit is possible in this graph is 0, 1, 2, 3, 4. Now, an Eulerian circuit follows an Eulerian trail. What does that mean? Well, it starts and ends at the same vertex. Right. But to be able to do that, it has to be connected, which it is. And according to my notes, vertices all have to have an even degree. Okay, so let's look at the degrees. There's 3, there's 3, there's 3, there's 2, there's 5, and there's 2. Well, if they've all got to have an even degree, at this moment in time, there are 4 odd degrees. What do I need to do? Well, I need to connect those in such a way as there are, in fact, different degrees, or make them even. So the way I could do that is, for example, connect the 5 to the 3 and connect that 3 to that 3 there. And so the minimum number of edges, as far as I'm concerned, would be 2. So the answer would be C. Question number 3, the flow of water through a series of pipes is shown in the network below, and the number on the edges is the maximum flow through each pipe in litres per minute. Okay, make sure that units are synced. The capacity of cut Q in litres per minute is. Now remember, when you work out the capacity of cuts, you're only interested in the flow that cuts in the right direction across Q. So in this situation, that value there is cutting in the right direction from left to right. This value here is cutting from left to right, and as is that version there cutting from left to right. The 3, this one here, is actually going from right to left and is not included. So when I do 5 plus 6 plus 3, I get 14, and so C is the correct answer. 2 graphs labeled graph 1 and graph 2 are shown below. Which of the following statements is not true? Okay, graph 1 and graph 2 are isomorphic. Well, basically isomorphic are exactly the same. And I'm looking at this already, and I don't know about you, but I see that there are 4 vertices here. There are 5 vertices here. So there are no way that these graphs are the same. And in fact, as it turns out, A is the correct answer. When we look through the other ones, graph 1 has 5 edges and graph 2 has 6. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Well, that's true, so that can't be because it's not true. It's looking for the one that's wrong. Both graph 1 and graph 2 are connected. Well, they're all connected because all the vertices are connected, so that's no. Both graph 1 and both graph 2 have 3 faces each. Well, if we go back, we know there's 1 face there, 2 face there, 3 face outside. 1, 2, and 3. So that's still true. So that's not that. And neither graph 1 nor graph 2 are complete. They are absolutely complete graph because they're all connected together. There's nothing hanging off the edge. And so A is my correct answer. Question number 5, the following diagram shows the distance in meters along a series of cables connecting a main server to 7 points A to G in a computer network. The minimum length of cable. Love these questions. I always choose a vertex, and then every time you're just trying to find the shortest number of, or the shortest number or the smallest number that's coming off. So I'm going to start here with the main server. And what choices do I have? I have 36. 15 and 33 is the ones that are coming off there. Well, 15, as far as I'm concerned, is the smallest. So there we go. I'm going to highlight that and put to D. Right, I've got D now. So looking at all the vertices now that come off the main server and D, I've got 36, 28, and 33. Which is the smallest value? Once again, it's the 28. So I can highlight this section here now. So I can highlight this section here now and repeat. Okay, so we've now got E and the main server. So we've got 36, 35, 30, and 33 to choose from. Well, 30 looks to be the smallest value. And so once again, I can go and highlight this section here. And I just keep moving through my diagram bit by bit by bit. So let's see, what have we got now? We've got 36, 33, 32, 40, 35 and 35 again. So which one is my smallest number? It would appear to be 32. So we're going to draw a line here. Okay, and once again we repeat. So let's see, we've got 36, 35, 40 and 33. Well, we're not going to connect that 33 back together because that makes absolutely no sense because we'll close that loop. So that's no use to me. So the smallest value there would be 35. So we're going to color that one in now. So to here, thank you very much. And what do we have here? 28 and 40. Well, that's going to be 28 And finally, hopefully that's going to delete that one, it is. And finally, we have the difference between 38 or 35. And so as far as I'm concerned, 35 is going to be my answer. So there we go. That is my spanning tree all done. And now what I'm going to do is add together all of the individual numbers here to make sure that I have the minimum length of cable, because those are length of cables. Firing up my CAS calculator, let's clear down what's already there. Yes, please. And let's see where we go. We've got 15. We're going to add that to 28, 35, 28, 32, 30, and 35. Hit enter. 203. And is that the correct answer? Well, I got it earlier today, and so B, as far as I'm concerned, is the correct answer. Okay, so for question 6, the map below shows all the row connections between 5 towns P, Q, R, S, and T. The row connections could be represented by the adjacency matrix. All right, there's no way I'm going to be able to look at those adjacency matrices. I tend to work this out myself. So the first thing I'm going to do is I'm going to draw myself a adjacency matrix. So there we go. Let's see if I can fit this all in. P, Q, R, S, and T, and P, Q, R, S, and T. Rightio. So let's see what we got. P to P. Now, obviously that means, do we have a loop running from P to P? And as it turns out, we actually do. That little thing in there is a loop drawn to try and trick you. But I can now say P to P is 1. But looking at the rest of this diagram, there are no other loops in it. So I can now put zeros everywhere diagonally. Q to Q, R to R, S to S, and T to T. Now what I'm going to do is just work my way around the diagram. And I know it's symmetrical, so let's do P to Q. How many ways are there from P to Q? 1. 2 ways. There's 2 ways there and 2 ways there. What about Q, P to R? P to R, can I get from P to R directly? Nope, there's no ways from P to R. So P to R is 0. P to S. P to S is 1 way, I believe. No, actually it's 2 ways. 2 ways from P to S. So P to S and P to T. Let's clear this down for a moment. Is there a P to T? There's 2 ways from P to T as well. Awesome. So now let's go from Q to R, because that seems to be my next one. So Q to R, there's only 1 way from Q to R. And from Q to R, there's 1 way there. What about Q to S? Q to S, there's just 1 way. 1 way from Q to S and 1 way from Q to S. And Q to T, Q to T, there is just that 1 way as well. 1 way from Q to T and 1 way from Q to T. So what have we got now? We've got R to S. R to S is just 1 way from R to S and 1 way from R to S. And R to T is 0. Nope. And nope. And finally, S to T. S to T is in fact 2 ways, because I can go this way or I could go that way around. So there we go. That's what I think the adjacency matrix is. Now, what if I'm wrong and that doesn't match anything? That's okay. We can just check to see if I've made a mistake. Right. So bringing the first, let's make that a bit smaller so I can try and fit all of them on in place. And so what have we got? 1, 2, 0, 2, 2. Well, that one doesn't seem to have 1, 2, 0, 2, 2. That doesn't. 1, 2, 0. So again, automatically I'm down to 2. B and E. 2, 0, 1, 1, 1. 2, 0, 1, 1, 1. Same. 0, 1, 0, 1, 0. 0, 1, 0, 1, 0. Yep. 0, 1, 0, 1. Ooh, same. 2, 1, 1, 0, 2. 2. Ooh. And in which case, that doesn't have it, and so B has to be my correct answer. Okay, so for question 8, we are looking at a directed note below shows the sequence of activities A to S that is required to complete a manufacturing process. The time taken to complete each activity in hours is also shown, and I've also pre-prepared my boxes because, yes, you know it, the number of activities that have a float time of 10 hours is. So I need to know what my float time is, and I know that float time is equal to my latest start time minus my earliest start time, which means I've got to go through my diagram that way and then that way, putting in all my values. Okie dokie. So when I go that way, I'm looking for the biggest number, and when I go that way, I'm looking for the smallest. I always write this on there just to help me out. So the start is 0. There's only 1 way to get A completed, and that's in a time of 5 hours. B, 4 hours is the only way to get to this vertex here, which tells me then that that's got to be 9. And to get to E, I'm going to add on another 3, which gives me 12. Now I start getting choices and all life gets very, very interesting. To get to D, there's only 1 way, so that's got to be 6. To get to C, I've got to add on 7 because there's only 1 way to get there, so that's 5, 6, 7, that gives me 12. And to get to h, now this is the first one that I have a choice. I can either go via d and g, which gives me 6 plus 3, which is 9, or along c and h, which is 12 plus 4, which is 16. And I'm looking for the biggest value, and so 16 is there. And I tend to write them below just to help me. Okay, likewise, to get to this vertex here, I can go E to J, I can go through J, I can go through F. So 12 plus 6 gives me 18. 6 plus 8 gives me 14. And so 18 is my biggest value. And so 18 goes in there. Right, let's see. I can only get to this vertex by going through I, so that gives me 19 there. And to get to M, this one here, I've got loads of choices, so I've got to get to this box first. I can either go via L or via K. So 18 plus 6 gives me 24, 16 plus 5 gives me 21, so that's going to be 24 there. And then we can get to that vertex there by either going through N, M, or O. So 19 plus 2 gives me 21. 18 plus 5 gives me 23, and 24 plus 7 gives me 31. 31 is my clear winner. There we go, 31. 31 to P, only way I can get there is 39. Down to R or through Q gives me 11, which is 42 or 40. So 42 is my biggest number. And then add the 9 gives me 51. There we go. Whoa. Now I've got to do it, yep, backwards. This time I'm going to choose the smallest of all of my choices. Now, what I'm not going to do is bore you with all that information. I've already pre-worked this out. So what I'm going to do is I'm just going to fade out and fade back in, or at least just the answers are going to appear, and then we'll talk about the answer. And there we go, there are all the values filled in. So what does the question say? The number of activities at a float time of 10 hours. Well, as I work around my question, then what I'm looking for is the difference in those two numbers to be 10. And in fact, the only one where that is true is that one there. And how many are there? There are in fact 1. And so B is my correct answer. A lot of work for that one question, yo. And these are the questions or the answers for the section on measurement and geometry. Very exciting. All right, so if these are the modules you have answered in the exam, awesome. These are the solutions you need. If not, go ahead, look for the next set of solutions. Helpful hints are given below. Okay, so question number 1, the 4 bases of a basketball field form 4 corners of a square of side length 27.43 are shown in the diagram. A player runs from home base all the way to first base, then to second base, then to third base, and finally back to home base. Minimum distance. To be able to do this, I have loaded up my trusty calculator, and basically what it's saying is, well, we know that that's a square. They've traveled 27.43, and they've done 4 of them, so the minimum distance must be 109.72. D was my correct answer. Question number 2, town B is located on a bearing of 60 degrees from town A, and the diagram that could illustrate this is given by. Okay, so basically town B is located from town A. So here is town A, there is my north line, and B is 60 degrees from. So I need to work clockwise, which means I've got to do it anti-clockwise on this video. So I'm looking at doing something like this. Here is my value of B, there is my north line, and which one does match that? Well, actually, the only one that matches that is, in fact, answer A. He says, not having put answer B even on the screen. So I'll show you answer B, but I can promise you that answer A is, in fact, the correct answer. Now, notice what I did there. I did a diagram, made my life much, much easier. Question number 3, an ice cream dessert is in the shape of a hemisphere, which is half of a sphere. The dessert has a radius of 5 centimeters. That's going to be important to me, I have a feeling. The top and the base of the dessert are covered in chocolate. Well, interesting, the top and the base. The total surface area in square centimeters that is covered in chocolate is closest to. Right, I know that the area of a sphere is given by 4 pi r squared. So a hemisphere must be half of that. So that's now going to be the top of that. I've got to add that to the base, which is a circle. And the area of a circle is pi r squared. So that gives me 2 pi r squared plus pi r squared, or 3 pi r squared. Knowing that, I can fire up my calculator and say, okay, so 3 times pi times my radius squared gives me 235.6 blah, 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 but the question says is closest to, so that would be 236. C would be my correct answer. Okay, question number 4. Triangle M shown below has side lengths 3, 4 and 5 centimeters. Awesome. 4 other triangles have side lengths and they're given there in the question. The question says, well, what are the triangles that are similar to M? Now, similar means that we've taken each of those side lengths and either kept them the same or multiply them by exactly the same value. So we made them twice as big, 3 times as big, 4 times as big. Now, as it turns out, 3, 6 and 8, nope, because that's not actually true. 4, 8 and 12, again, I can't multiply 3 anything to get to 4 and 4 to get to 8 and 12 to get to 5 or whatever it is, or 5 to get to 12, it's just not going to work. So actually, as it turns out, 6, 8 and 10, because if I multiply this triangle all by 2, the side lengths become 6, 8 and 10. And if I multiply this triangle by 3, I get 9, 12 and 15. And there we go, 9, 12 and 15, 6, 8 and 10. So P and Q are the triangles, so E is my correct answer. Question 5. In triangle ABC, the point D lies on the line AC as shown in the diagram below. The length of the line BC is equal. So what it basically says, if that's the case, this is an isosceles triangle. And this angle here and this angle here add up to be exactly the same thing. So which of the following statements is true? So we're looking for one that is true, so 4 of them won't. A, the angle BAD, which is this angle here, is equal to the angle ADB. This angle here, nope, not at all. All right, that's not an isosceles triangle, so that's not true. I don't think so. The angle ADB, this one here, is equal to BDC. This angle here, nah, not at all. Nope, 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 nope. So there we go. That is not at all. Can't be true. The sum of the angle ACB, so this angle here, and the angle ADB, this angle here, is 180 degrees. This is actually the correct answer. Now the reason being is, we know that this here is a straight line. So this angle here and this angle here adds to 180 degrees. And what do we know? We know that this angle here and this angle here are exactly the same size because it's an isosceles triangle. And so, ladies and gentlemen, the correct answer is in fact C. You can work out that D and E are also not correct, but I'm going to move on to question 6. For question number 6, all cities in China are in the same time zone. Awesome. Wuhan, 31 degrees north and 140 degrees east, and Chengdu on 31 degrees north and 104 degrees east are both cities in China. Awesome. On one day in January, the sun sets in Wuhan at 5:50 p.m. Now, one of the things you need to know here is when the sun rises, or where the sun rises and where the sun sets. So, assuming that 15 degrees of longitude equates to 1 hour time difference, the time difference in the sun sets in Chengdu on the same day is. So what I tend to do is I always draw a circle so that I know where they are on the latitude, all right? So I know now that this, let's say this is W, Wuhan, and I know that that's 114 degrees east, and Chengdu must be on this side because we go east back to 0. So this is Chengdu, and that's 104 degrees east. We know that 15 degrees of longitude equates to 1 hour time difference. So I now know there is 10 degrees of difference. If 15 degrees is equal to 1 hour, then what we know is 15 degrees is equal to 60 minutes, or 1 degree is then equal to 4 minutes. And so 10 degrees is going to be equal to 40 minutes. So there is going to be a difference of 40 minutes between the sun setting in Wuhan and Chengdu. But the question is 40 hours advanced or 40 hours behind? And this is where we need to make sure that we know. The sun actually rises in the east and sets in the west. So actually the sun moves this way here. So the sun will set in Wuhan before it sets in Chengdu. So if we know that there's a 40-minute time difference and it sets here at 5:50 p.m., then I'm going to add on my 40 minutes, which gives me 6:30, and D is my correct answer. Okay, so question number 7. A can of dog food is in the shape of a cylinder. The can has a circumference of 18.85 centimeters and a volume of 311 centimeters cubed. The important part of this question is the fact that it is a cylinder, and we know that cylinders have a volume given by pi r squared times the height. Now it's looking for me to find the height. It's given me the volume, so the volume is 311 is equal to pi times r squared, the radius. Now I don't actually know the radius of this. That's a little bit annoying. Can I find it? Well, yeah, because they've given me the circumference. So I know the circumference is equal to 2 times pi times radius. So 18.85 divided by 2 pi is equal to my radius. So I know that that's now 18.85 divided by 2 pi, all squared times by height. Excuse me. And when I put all of this into my calculator, I get that the height of that actually works out and is closest to 11. So D is my correct answer. I'll leave it to you to put it into your calculator if you need to, but I promise you 11 is the correct answer. I have to say I really liked this question. 4 identical circles of radius r are drawn inside a square as shown in the diagram below. The region enclosed by the circles has been shaded in the diagram. The shaded area can be found by. Okay, so this is what I did. I went, well, I can split this into 4 squares. Not the best of colors to choose, but I can split it into 4 squares. And I can find, if I imagine that one of those squares has got this circle in it here, then I can find the area of that little bit here by, well, find the area of the square, subtract the area of the circle, which will give me all 4 of these sections here. And I know that because there are 4 sections, if I then divide that by 4, I'll get this one little section in the corner. How do I find the area of the square? Well, we know the radius of that circle is r, which means the width of the square is 2r. And because it's a square, we now know that's 2r by 2r. So the area of the square is given by 2r times 2r, which is 4r squared. And the area of the circle is pi r squared, which I'm then going to divide by 4 to give me this little corner section here. But hold on a minute. How many squares do I have? I've got 1, 2, 3, 4. So it turns out I've got 4 of these little sections, which when I times that by 4, they cancel. And so I can work out the area of that is 4r squared minus pi r squared. And where was 4r squared minus pi r squared? Question number 8, B, is my correct answer. Okay, so question number 1, the final section in this exam is graphs and relations. I'm fairly sure there are no more after this, and so let's power through. The graph below shows the water level in a creek in meters over a 12-hour period. Compare the water level at 8 a.m. So here's my water level at 8 a.m. It's about 0.9. The water level at 12 noon is about 2.4. So compared to the water level at 8, the water level at 12 was closest to, well, if I do 2.4 minus 0.9, I get about 1.5. It's obviously higher. Which one of those is closest to 1.5? B. So the answer is 1.4 meters higher. Okay, question number 2. The cost C dollars of using K kilowatt hours of electricity can be calculated using the equation below. And there we go. We have a wonderfully beautiful equation. So from this equation, it can be concluded that there is no fixed charge. Absolute rubbish. This value here is a fixed charge because it's not related to the times by K. It's just a number. If K was 0, we get charged 52. If K is 1, we still get charged at 52 plus a little bit more. So there is in fact a fixed charge which discounts A and B. A fixed charge of 15 cents? I don't think so. The fixed charge is $52. And again, do you see what's happened there? 3 values have automatically gone, leaving 2 to choose from. So a fixed charge of 52, yep. The electricity used is charged at 0.5 per kilowatt hours. That's 15 cents per kilowatt hours against $15 per kilowatt hours. Nap, it's not $15 per kilowatt hours. It's actually 15 cents. And so there we go. D is my correct answer. I have to say I really liked this question as well. I love these questions in this section. A shop sells 2 types of discs, compact discs and DVDs. CDs are sold for $7 each and DVDs are sold for $13 each. Bonnie bought a total of 16 discs for $178. How many DVDs did Bonnie buy? The trick to this question, funny enough, was DVDs. So this is actually linear. And what I can now say is I've got 16. So I know that CDs plus DVDs, I know the total number is 16. So I can write that as an equation. C plus D is equal to 16. I know that CDs cost $7. So 7 times C plus $13 per DVD must give me the total amount of $178. I can't work that in my head, but I just so happen to have something that can do this for me. And so bringing up my calculator and putting in some equations, I'm not going to use C and D, I'm going to use X and Y. So I know that X plus Y is equal to 16. Going down, I've got 7x plus 13y is equal to 178, delete 178, and solve that for x and y if you will, which gives me 5 and 11. So my answer is 5, yes? Nope. Because that's CDs. Remember, x is 5 and y is 11, so y is my DVDs, and so E was in fact the correct answer. Ooh, trick. Ooh, annoying. The graph below shows a straight line that crosses the x-axis at those 2 points and crosses the y-axis at 0, q. Once we define the intercept, to be able to do that, find the equation of a straight line. Now, I always use the same equation, y minus y1 is equal to mx minus x1, where m is the gradient of the line and x1 and y1 is a coordinate. So the first thing I'm going to do is I'm going to put that coordinate in. So that's going to be my x1 and y1 value. So y minus the y value is 8 is equal to m. I don't know what that is, but we'll work it out in a moment. Minus 6, which is plus 6. Now, how do we find the gradient? It is rise over run, which is y2 minus y1 on x2 minus x1. So y2 is 8 minus 0 over x2, which is minus 6 minus 10, gives me 8 on 4, or 2 as my answer. So my gradient is equal to 2. When I do some multiplying this out, x is equal to 2x plus 12. Add 8 to both sides gives me 2x plus 20. And those of us who are aware that there is my y-axis intercept. So the value of q happens to be 20. So D is my correct answer. Question number 5, Giovanni makes and sells toy train sets. I don't know what that's all about. I sound like the Count from Sesame Street. I'm the Count and I love to count. No, you don't. That's weird. So, Giovanni makes and sells toy train sets. Each toy train costs $40 to make and sells for $65. So, I automatically know from this question here that for each toy train or train set or whatever it is, he makes 25 bucks. That's his profit. Yeah? Giovanni also has a fixed cost for batching the toys. Okay, oh, I keep doing that. Sorry, let's actually highlight that. Fixed cost for making a batch of toys. Last Sunday, Giovanni sold 35 toy train sets for a profit of $250. Okay, so his profit is actually 25 bucks. So if I work out what 35 times 25, that's how much his real profit is. That's how much he should be getting. So firing up my CAS calculator, let's clear this down so it's not confusing because that was a previous question. If we do 35 times 25, what do we get? We get $875. $875. That was his actual profit. But what happened was he only really cleared $250. So if I take away $250 from that, what do I get? $625, which does in fact give me B as my correct answer. So that's his fixed cost. That's what he obviously had to pay before he had made his, in my words, real profit. Okay, ladies and gentlemen, question 6, a recipe for a fruit drink lists both pineapple juice and mango juice. Now, I'm really sorry, guys. These questions absolutely mess with my head. I to this day, have no clue how to do these questions. Maths Guru, maybe not for this particular one, but at this moment in time, I'm just going to fudge it a little bit and tell you the actual correct answer is C, and we'll leave it at that and update this answer at another time. So for question number 7, the feasible region for a linear programming problem is shaded in the diagram below. You've got an equation, dotted line passes through the points V and W in the diagram, has the same slope as the objective function for the problem. Now, the minute I know that, I know I've got to try and move that line up and down and see what happens. The minimum value, all right, so the minimum value of the objective function can be determined by calculating its value at, well, what I want to do is the minimum, so I want to go to the furthest left of that diagram I possibly can. And as it turns out, because that's parallel, it'll actually go through both S and T, and in fact, any line segment along S and T. So E is my correct answer. Probably one of the easiest feasible region questions I've known. And question number 8, final question in this section. Jenny and Alan's house is 900 meters from a supermarket. Jenny's at the house and Alan's at the supermarket. Awesome. That was the trick to this question. At 12 noon, Jenny leaves the house and walks towards the supermarket. And at exactly the same time, Alan leaves the supermarket and walks towards the house. Now, Jenny's plan walk is modeled by that equation, or a series of equations. So what I actually did was I drew a graph and said, okay, so my values are 2, 6, and 10. And when I actually worked these out, that gave me 240, it gave me 640, and it gave me 900. So there was a cross there, and across there, and across there. Now, if you're not sure where I got those values from, I put 2 into this equation here, gave me 240. I could put 6 into this equation here, which gave me 640. And I put 10 into that equation there, it gave me 900, right? So they gave me the important points in the graph, which when I connect them together, and it's going to seem like it's a straight line, but at this moment in time, it doesn't really matter. It says Alan's plan walk is modeled by that equation, and basically they want to know when they meet. So to be able to work out when they meet, I've got to find where the 2 lines or 2 equations, put them equal to each other and work out where that is. Now, Alan's equation is this one here. So it's minus 80t plus 900. That tells me he's starting at 900, which is there. And so what I need to do is work out, well, where's it going to cross? Is it going to cross at the first section, the second section, or the third section? And the way I did that was I said, well, okay, if I know the equation is that, and I know that I've got these points t equals 2, sorry guys, but for some reason there's bugs everywhere in my house. It's probably because it's a swelteringly hot day. So 2 is there. So what I did was I put 2 into this equation here, and what came out was 740. So after 2, what does t stand for? Is it minutes? It can't be minutes. Is that? Yeah, it is t minutes. So after t minutes, 2 minutes, he was 740 meters. Well, that's not crossed any lines. So what I did then was I said, well, okay, where is he when I put 6 into his equation? And when I put 6 into his equation, I got 420, which would suggest that actually he's going to cross in this section here. All right, that's the time when they're going to be roughly the same, not the same, they're going to be the same time away. Anyway, put the 2 equations equal. So that means I've got this equation here, and I'm going to put it equal to that equation here. So when I do 100t plus 40 is equal to minus 80t plus 900. I add, what am I going to do? I'm going to add 80 to both sides. It gives me 180t. I'm going to take 40 away from each side, which gives me 860. And when I divide those together, what I get is 860 divided by 180. I get 860 divided by, thank you calculator, 180, 4.777. So they meet at 4.7777 minutes. That's where they meet. That's not what they actually want, 4.77 minutes. The question says, well, they will meet when? So what I'm going to do now is put that value back into Alan's equation. So when I do that, when I put that back in, I'm going to say, right, so I want minus 80, negative 80, times my previous answer. Let's use the answer from my calculator, plus 900. Gives me that he's 518 meters. So we now know that Alan is 518 meters from the supermarket. So is that an option here? Alan will have walked 580 meters to the nearest meter. Just by luck, D is my correct answer. And ladies and gentlemen, that concludes the answers to the 2019 Paper 1 for Further Maths. Hopefully you have found this useful. If you haven't already done so, please do me a favor and subscribe. Head over to mathsguru.com. But otherwise, hopefully I'll see you in another full solution video coming soon. Take care. Have a good day.